Jupiter is the true king of planets. Its diameter is 88,846 miles, making it 11 times larger than Earth. And its mass is a whopping sextillion pounds. That's more than the mass of all the other planets in the solar system combined. It's no wonder such a giant was noticed even in ancient times. It was the ancient Romans who named the planet after their god of the sky, thunder, and father of all gods. But here's what's interesting. Despite its gigantic size, Jupiter is actually made of gas. It is 90% hydrogen and almost 10% helium. So, there's no solid surface. If you tried to land on it, you would simply fall into the layers of the atmosphere, which extend thousands of miles deep. Speaking of the atmosphere, it consists of powerful storms that create Jupiter's famous bands. And the most grandiose storm is the Great Red Spot. Its width is about 10,000 miles, meaning it is more than twice the size of Earth. Moreover, this hurricane has been raging for at least 350 years. Jupiter's power is not limited to its hurricanes. It has the strongest magnetic field. Among all the planets in the solar system, it is 20,000 times stronger than Earth's. This field creates powerful radiation belts that can be deadly for spacecraft, vehicles, and Jupiter also has a lot of moons. Currently, 95 moons are known. The largest of them is Ganymede. Its diameter is 3,273 miles, making it even larger than the planet Mercury. That's quite a serious company for our giant. And yes, if Jupiter were 80 times more massive, it could become a real star, because thermonuclear reactions would start in its core. I'm sure I managed to pique your interest. And I haven't even revealed a small fraction of the most interesting parts. The best is yet to come. More about the structure of Jupiter. Scientists have discovered that Jupiter is mostly composed of gas. But that doesn't mean the planet's structure becomes simpler because of it. Now we will examine the structure of Jupiter layer by layer. Let's start with the atmosphere. It extends thousands of miles deep and is mainly composed of hydrogen and helium with small amounts of ammonia, methane, and water vapor. These substances are what create Jupiter's famous bands and its hurricanes. A bright example is the Great Red Spot. But what lies beneath this turbulent atmosphere? This is where what makes Jupiter truly unique begins. The deeper we go, the more the pressure increases. In the lower layers of the atmosphere, the gas becomes so dense that it turns into a liquid. This means that Jupiter does not have a clear boundary between its atmosphere and its inner layers. It smoothly transitions from gas to liquid. Descending even further, we can observe something extremely rare in the solar system, a layer of liquid metallic hydrogen. Such a layer is also present on Saturn, which shares common features with Jupiter. This substance is not found on Earth, but under pressures of several million atmospheres, hydrogen changes its properties and becomes similar to a metal. It is this layer that creates Jupiter's powerful magnetic field. But what lies hidden at the very center of the planet? Scientists believe that there is a solid core there. Its size is approximately twice as small as Earth, but its mass is up to 20 times greater. However, what exactly this core is made of remains a mystery. Some researchers suggest that it is rock and metal, while others believe it might just be smeared out due to the immense pressure. Let's note for ourselves that Jupiter is not just a gas ball. It is a complex planet with dense layers, the highest level of pressure, and unique physical and chemical processes that we are only beginning to study. Got it? Let's move on. Radiation on Jupiter. Jupiter is not only the largest but also one of the most dangerous planets in the solar system. And the main threat to the planet's researchers is the radiation, which can thwart the efforts of the researchers. Get to know Jupiter up close. I already mentioned that Jupiter's magnetic field is extremely powerful. Because of this, giant radiation belts filled with charged particles have formed around the planet. To help you understand the scale, imagine this. The radiation level near the planet exceeds the lethal dose for a human by 1,000 times. Such extreme conditions make studying the planet incredibly difficult. Any equipment entering Jupiter's radiation belts is literally fried by the intense stream of particles. Electronics fail, and the equipment sustains severe damage. But scientists still tried to get closer. In 2003, the spacecraft Galileo, which studied Jupiter from orbit for 8 years, was deliberately directed into the planet's atmosphere. This was done to prevent the potential contamination of other solar system moons with Earth bacteria. Galileo managed to penetrate 125 miles into Jupiter's turbulent atmosphere before contact was lost. Scientists do not have enough information to understand exactly how Galileo failed. It could have been crushed, melted, or completely disintegrated due to the intense pressure and temperature. Another mission is the Juno probe. It was launched in 2011. The probe has been in orbit around Jupiter for a long time and has significant radiation protection. The vital electronics were hidden in a titanium vault weighing 440 pounds, capable of withstanding a radiation dose 100 times greater than what is lethal for a human. And even with such protection, the spacecraft had to adjust its trajectory to minimize exposure to the most dangerous zones. And here's the most interesting part. If you were near Jupiter without protection, your cells would start to break down in just a few minutes. And any spacecraft without special shielding would last no more than a few hours. Jupiter is an amazingly beautiful and simultaneously dangerous planet. In other words, a deadly beauty. The auroras on Jupiter. Everyone knows that the northern lights regularly appear on Earth. I hope many of you have seen it with your own eyes. This aurora is hundreds of times more powerful than on Earth, and it never stops. But why does it happen? The auroras on Jupiter are related to the planet's rapid rotation. The gas giant completes a full rotation around its axis in about 10 hours. In doing so, it also drags along its magnetic field. The source of particles for the aurora is the volcanically active moon Io. Its 400 volcanoes constantly eject a huge amount of various particles into space. These particles enter Jupiter's orbit, turning into plasma there. However, the planet's rapid rotation repels this plasma, as if splattering it, back into space. And here's what's truly amazing. The auroras on Jupiter glow not only in the visible spectrum, but also in the X-ray spectrum. This means that if you were looking at it with the naked eye, you would see giant, glowing rings at the poles. And if you look at the planet through an X-ray filter, you would see bursts of energy that release more power than thousands of atomic bombs. Jupiter's auroras are also unique in that they don't just flare up from time to time like on Earth, but burn continuously. This is because the planet's magnetic field constantly captures and accelerates charged particles, continuing the light show. Well, let's move on to the next interesting facts about Jupiter. Jupiter's gravity. The facts about Jupiter's gravitational field are no less impressive than those I've already told you. For example, did you know that Jupiter is called Earth's protector? Yes, it's not fake. And that's because Jupiter literally acts like a cosmic vacuum cleaner. Its gravitational pull is so strong that it attracts asteroids and comets that could crash into Earth. For example, in 1994, astronomers observed the massive comet Shoemaker-Levy 9 collide with Jupiter. The impact was so powerful that it left marks on the planet larger than Earth. If the comet had come to us then, I probably wouldn't be telling you this story now. By the way, an interesting fact on the topic. The aforementioned comet became a phenomenon. It was the first celestial body to fall on Jupiter in all the time scientists have been observing. The comet was a chain of fragments flying one after another. Jupiter's gravitational force is several times greater than that of any other planet in the solar system. If you personally found yourself on its clouds, you would weigh several times more than on Earth. Imagine, a person who weighs 60 kilograms on Earth would weigh about 150 on Jupiter. A heavy burden. Jupiter's gravity directly affects its numerous moons. It stretches and deforms them. The most impressive example is the already familiar moon Io. Its surface constantly bulges and contracts under the influence of gravity, which heats the interior and causes volcanoes to erupt with a force not found anywhere else in the solar system. Many scientists believe that in the early days of the solar system, Jupiter might have traveled closer to the Sun and back, altering the orbits of other planets. It is possible that it pushed Uranus and Neptune further from the center of the system, and perhaps even caused the failure of a full-fledged planet to form between Mars and Jupiter, leaving behind an asteroid belt. The scientist's theory is very interesting and makes one ponder the real role of Jupiter in the structure of our solar system. While scientists contemplate the possible past of Jupiter, I will tell you about its numerous moons. Jupiter's moons. Jupiter is by no means alone. In 2023, the number of Jupiter's moons was 95. For now, this data is current. Now I'll tell you about the most interesting ones. Besides, I talked about this moon earlier. Let's start with Ganymede. It's not just a moon, but a true giant planet in miniature. It is larger than Mercury and Pluto. It is the only moon in the solar system that has its own magnetic field. Scientists believe that beneath its icy surface lies an ocean that could be up to 50 miles deep. That's 8 times deeper than the Mariana Trench on Earth. And now Europa. Scientists do not rule out that conditions suitable for life could form on this moon. This moon is covered by an ice crust several miles thick, but beneath it, scientists believe, lies a liquid ocean containing twice as much water as all the oceans on Earth combined. Europa also amazes with its appearance. Its surface is crisscrossed with cracks and lines, like a giant marble sphere. Next, Cali 100. This moon is covered with craters, and its surface is considered one of the oldest in the solar system. But most interestingly, beneath the outer shell of the moon, there might also be hidden an underground ocean. This means that Cali 100 could also be a good candidate for the emergence of life. But there are lesser-known moons that also deserve attention. For example, Amalthea is a tiny, irregularly shaped moon that literally glows in the dark. Its surface is covered with a layer of reddish dust that reflects sunlight, creating a mysterious glow. Amalthea truly looks unusual. If I hadn't known it was a moon, I would have surely mistaken it for an asteroid. The unrevealed mysteries of Jupiter. In this video, we are dealing with a true mystery planet. Despite decades of research, Jupiter still hides many secrets. And it seems that it doesn't really want to be studied. Scientists, however, regularly make discoveries, but an interesting pattern emerges. The more we learn, the more questions we have. One of the biggest mysteries is Jupiter's core. We know it exists, but what it's like remains a mystery. Some data suggest that the core is dense and consists of heavy elements. Others suggest it might be diffused under immense pressure. Even the Juno mission, which has been studying Jupiter for quite some time, has not yet been able to provide a definitive answer. To understand what's inside, scientists need more powerful probes and possibly even a mission with test drilling. But how do you drill into a planet that has no solid surface? And is it possible for humans to create technology capable of approaching Jupiter at a working distance? Another mystery: the Great Red Spot. This gigantic hurricane, larger than our planet, has been raging for several hundred years. But why doesn't it disappear? On Earth, even the strongest hurricanes dissipate within a few weeks. Yet here, the hurricane persists for centuries. To be fair, it is indeed shrinking. At the end of the 19th century, its diameter was about 25,000 miles. And today it's just 9,000, but still, it's an unprecedented phenomenon. Researchers are now trying to understand what fuels it and when the hurricane will completely disappear. In addition to what has already been said, consider that there may be processes occurring inside Jupiter that we can't even model. There is a hypothesis that at a depth of 1,000 miles, there could be icy rains of ammonia or unknown forms of hydrogen resembling lava. But unfortunately, it's currently impossible to verify these hypotheses. A whole range of questions is related to Jupiter's moons. We know that an ocean is hidden beneath the surface of Europa. But is there life there? For that, an expedition is needed that can drill through the ice cover up to 12 miles thick and send a probe there. The Europa Clipper mission, which will head to the moon at the beginning of the next decade, might give us the first hints of an answer. And finally, the question that interests everyone: why didn't Jupiter become a star? It has the same composition as the Sun, but it lacked the mass to ignite. If it were 70 times heavier, we would have a binary star system. Jupiter is a direct reminder that the universe could have formed very differently. But still, despite the many questions that remain about Jupiter, we cannot overlook the progress made by scientists. They have made giant strides in studying this planet, and we can only wish them even greater success. Meanwhile, Jupiter remains shrouded in mysteries. Perhaps the most astonishing discoveries await us in the future.